potential.
There you go. Exactly. Come on, I'm asking you dumbass questions. Give me dumbass answers. That's exactly what I want. Always challenge authority. No, in this case, you are doing your insulation resistance is going to be a DC resistant or a DC voltage injection that we're dealing with there. So we inject 2,500 volts into our sample. We have our breaker in the open position and we measure across the bead hole. We're going to say, I found, what's a passing value? What's the minimum passing value?
5,000.
5,000 watts. Mega ohms, all right. Which is how many giga ohms?
5 million, right?
You went the opposite direction.
5.
5. There you go. Something again to remember when you're taking your NETA exams. They will do that to you all the frickin' time. They will say, all right, they're going to make sure that you can go up and down the SI scale. It does matter. So going to 5 million mega ohms, I mean, that's fantastic. That's fantastic resistance. Passing with fine colors. No, 5 giga ohms that we have there. But we did even better. So on a 2,500 volt megger, we received a value of 286. No, I can't make the math easy for you. Giga ohms. What was your measured leakage currents? What did your mega ohm meter measure for leakage current? And yes, this is one of those calculate it quick and put it on your placard if you want to be pelted with a beanbag. And I do not want any 10 to the negative 6 or a whole bunch of zeros. I want you to give it to me in the most convenient unit you possibly can.
Nine nano ohms or nano amps.
So I got writing calculators also, just making sure. Yep. So not quite. So nanoamps is what we had. Very good try, Mike. So you were off by an order of magnitude. So you had microamps. This would have actually been nanoamps. So what did you? So I guess how many zeros were there when you divided?
6.
So 6 would be mega, wouldn't it? So in this case, it was giga. So this would have been 9 zeros after 286. So you got very close, but you got the wrong order of magnitude. Which, let's take that as an opportunity to talk a little bit about how a NETA question is structured. Almost all of them, with very few exceptions, are going to be select one of 4 choices of the multiple choice bank that you have. So great for you. That means the answer is there. But when a question is put together, what is called the stem, the question itself is going to have a single key. That is the right answer that you are looking for. And a well-structured question is going to have distractors. One of them, maybe 2 of them, will be near distractors, and one of them will be a far distractor. So the far distractor is, if you are really off the beaten path, there's no way you should be getting that far distractor. But the near distractors might be exactly what you got. They might give it to you and you say, oh, okay, the answer's there. Great, I'm done. But it's meant to make sure that you're keeping track of the values that you have up there. So another really important part of prepping for your NETA exam, if you're away from high school for a bit, if you're away from your education where you worked on the SI units, just make sure that you have those prefixes committed to memory, that you know how to navigate and make things larger or smaller, because you're going to see that on a regular basis. All right, next one, contact resistance. Contact resistance, what are we measuring?
The resistance in the contact.
Yeah, exactly. Now, what do we use to measure that?
The ductor.
Yeah, use inductor. And what does inductor spit out? What's the value that it spits out?
Current.
You used inductor, right?
Yeah, like it. Wait a minute.
It's okay. Look at it in your mind's eye. Because I'll say another thing that the NETA exams do, and this is, Tom, this is important for you as well as for you, Mike, that it is not unusual. They will just show you pictures of equipment, or they'll describe how equipment looks, and they'll expect you to know what it is. Because everyone who has used a ductor should know that it has either a dial or a selection that allows you to select the amount of current that you're going to apply to a system. Likewise, you should know that a ductor is going to have 4 terminals on it, right? What are the 4 terminals?
You know what? I've never really put that.
All right, now you're going to pay attention to it. You're going to look at it.
Like I've just kind
It's-
of done it.
It's plus P, it's P1, P2, C1, C2, or V1, V2, C1, C2. I have a game that we can play in a future class that just goes over what the different types of terminals you'll find on something like that. But our ductor, much like our insulation resistance tester, is going to measure the amount of what? It's going to, is it?
Well, the screen reads in resistance.
The screen reads in resistance, but just like our insulation
So
resistance,
if
it
you put
doesn't
the car
affect.
actually measures voltage.
There you go, exactly.
Huh.
Oh, hell yeah, Mike, come on. We're
I
rocking
get
this.
the simple ones.
You're rocking this, yes. So our ductor is going to apply a known current to a sample. And it's going to determine just how much voltage drops in between the 2 terminals of our ductor, of our contact resistance tester. Because our ductor is going to be applied to, let's say, a bolted connection where we have 2 pieces of electrical busing bolted together. And we're going to apply our ductor here and here to measure just how much resistance we have between those 2 contact points that we're dealing with. Now, does the NETA guide tell you what are good and bad values for ductor? I'll give you a spoiler because we're running low on time. No, it does not. It does not give you absolute values because the range of acceptable resistances varies pretty wildly. Now, what it does say is that for things like multi-pole mechanisms, such as a circuit breaker, you should vary by no more than 50% high to low, so that if you have pole to pole, exactly. So if you have a pole that, if you have A phase is at 50 microohms, then at, excuse me, then B phase should be no greater or no less than 25 or 75 that you have there. That way you have no greater than 50% variance pole to pole that you're dealing with. So let's do 2 things here with the equations that we